Well, good evening, everybody, and welcome to another edition of In the Cosmos Live, brought to you by the De Anza College Planetarium. Thank you for joining us this evening as we take a look at the moon and some other things. Joining me, as always, is my good friend Mike. So, Mike, why don't you go ahead and wave and say hello to the folks?
Hey there, Toshi. Nice to be with you tonight. And I'm very happy to have a lot of guests tonight to be able to sit with us on this very cold night to me. But here in California, what's cold? I think it's about 40, between 45 and 50 degrees. So compared to people who might be in real weather, it's pretty California-like. So I'm looking forward to showing some stuff here with my telescope. It's all set up. And why don't you take it away, Toshi?
Yeah, and we were worried a little bit about the weather, right? The weather was kind of dicey. The last couple of nights, it was pretty clear, but the weather tonight was sort of partly cloudy, which is sort of the astronomer's worst forecast because it doesn't give us any information. But Mike, just let us know, what does the sky look like for you?
Yeah, I see a very brilliant first quarter moon. I see Jupiter, some other stars. Honestly, conditions look pretty good, Toshi. I don't want to jinx them.
All right. Well, why don't we go ahead and get started with the program here? We like to ask a lot of questions, and if you have questions for us, you can feel free to put that in the chat. We will do our best to answer as many of those as we can. So don't be shy about your questions, and it's always helpful for us if you're also outside and you can be looking at the things that we're telling you to sharing with you on things that you can find in the evening sky tonight. Hopefully, it's clear where you are as well as we celebrate this first quarter moon here in December. Now, it is our plan tonight to focus on the moon, but we wanted to start off in giving just a little overview of the sky here with some visible planets and whatnot, and also a couple of dates just to sort of remind everybody. Mike made note of how dark it is at the moment, how cold it is at the moment. We have our earliest sunsets here. It's December 11th. So we're just coming off of some of the earliest sunsets that we get for the year, which are usually on December 3rd through the 9th, with the sun setting as before 5 o'clock here in Cupertino. And we're about 10 days from the winter solstice, which is happening on December 21st. And that'll be about 8 a.m. Pacific time for us. And again, just in about 10 days from now. So the days are getting shorter, but for astronomers, we like that because it means that the nights are getting longer, so we can do some good observing. The other date that we want to make everybody aware of is that in 11 days from now, the James Webb Space Telescope is going to launch. After a long time of waiting, this telescope has been in development for a long, long time. So we're hoping to see a successful launch. That'll be December 22nd. And it's launching our time here on the West Coast, 4:20 a.m., which is quite early for us. But if there are visitors watching from other parts of the country, maybe back east, it's at a more reasonable hour. But it's actually launching from French Guiana. And that'll be the successor to the Hubble Space Telescope. And even though the James Webb is going to be primarily an infrared telescope, but we expect a lot of pretty images and a lot of great science to come out from the telescope, from this new telescope. And if you want more information about the James Webb, you can check out the website for the James Webb Space Telescope at NASA's website for the scope. Mike, did you have anything to share about the James Webb? Anything that you'd like to say about it?
Well, I just what's been said in the discussions that NASA has been broadcasting about it for people who are interested. This particular telescope is a very exciting, not a replacement, but sort of an add-on to the Hubble Space Telescope, which is still functional. And this particular telescope is very exciting because it is very is very high performance telescope in the infrared. And as you know, Toshi, infrared data can tell us things about a lot of history and future formations of stars and stuff like that. So astronomers are looking forward very strongly to to the James Webb Telescope. And like you say, we've been waiting for it for a long time, so it's exciting to have it this close.
Yeah, and one more thing just to note is that one thing that is a little bit worrisome is that, as some of you may know, that there were some early issues with the Hubble, and also that a lot of the instruments have been upgraded, and that's because we're able to send shuttles up to the Hubble Space Telescope to replace parts and whatnot. But we're not going to be able to do that with James Webb, will we, Mike?
No, actually, James Webb is going to be in a much more interesting position. And I believe it's one of those Lagrange points that they're aiming for, right, Toshi?
Yeah, so it'll be at one of the Lagrange points, which means it's in a stable position away from Earth, but we need it to be far away from Earth so that we can help shield it from some of the radiation from the sun, because the telescope needs to be kept very cold. So that is one little point of concern. If that something goes wrong with the telescope, hopefully nothing goes wrong, knock on wood. But if anything does go wrong, it's too far away to send any servicing missions, so we're not going to be able to upgrade the telescope or anything like that. But I do see in the chat that we do have folks tuning in from Palo Alto and San Jose, and from Arizona as well, and as well as Belmont, California here. So again, welcome to everybody. And if you're just joining us, we're just about to get started here. And I thought we would start off by, again, taking a look at that evening sky, what sort of things we might be able to see. So we're going to turn to our trusty friend Stellarium to get an overview of what the night sky looks like here for us. So we're looking here at the western part of the sky. This is from Cupertino here. And as you're looking at the part of the sky here, if you're lucky enough to have really dark skies like this, then you can see a lot of stars, but a couple of the brightest points in the sky right now are a couple of planets that are visible. We've got here low in the southwest, the planet Saturn, and a little bit higher up, about 25 degrees above the horizon at the moment here, is the planet Jupiter. And we'll be looking at Jupiter through Mike's telescope in just a few minutes here. But again, just a little overview of the evening sky, some things that you might be able to see. We also see over towards the north of west here, 3 bright stars here, and those are the 3 brightest stars in something called the summer triangle. And even though we're right in the midst of winter, we can still see the summer triangle made of these 3 stars here, which are the stars Deneb, Vega, and Altair. And those 3 bright stars in the summertime, they are rising in the east, but here as we approach winter, they're getting ready to set over in the west. But those are some bright stars that you might be able to see in your sky if you're looking towards the west. As we pan a bit over towards the southern sky here, we can see the moon in our view. And again, we'll focus in on the moon in a little bit. But above the moon, there's a group of stars here that form a square here. And that square is part of the constellation of Pegasus, the flying horse. And there's a shared star with Andromeda, the princess there. And again, just to give an idea of what the artwork looks like for them here, we've got Pegasus with his wings, only half a horse showing here. And then there's Andromeda who's trailing away there. But the easiest way to find Pegasus or to note Pegasus is to look for this square of stars that are all just about the same brightness, but it makes a pretty solid square up there in the sky. So that's something that you can be looking for as well in the sky. And one more or a couple more constellations to be taking a look at as I sort of pan further back down towards the horizon and make our way towards the east. A couple of those winter constellations. I know, Mike, there are a couple of your favorites. As I center in looking almost directly due east, there's one bright star here. And if in my view here on screen, it looks a little bit orangish or reddish, that's a bright reddish orangish star. It's actually a red giant star in the sky that you can find. That star is called Aldebaran, is the name of that star. And I'm going to zoom in just a little bit. So we've got Aldebaran, and that is the brightest star in the constellation of Taurus the Bull. And there's sort of a V shape of stars that make up the main part of Taurus. The artwork shows that it's a bull here. So the V shape is the face of the bull. And then we've got stars that extend out this way to form the horns, and then some stars that form the body of the bull, as well as sort of where his legs are. In the right on the shoulder of the bull is a group of stars that are called the Pleiades, or the Seven Sisters, visible there in the sky. And then following Taurus in the sky, a little bit lower in the sky, hidden behind maybe some trees, but it's quite low at the moment, is this very famous constellation. And it's famous most for these three very bright stars here, which form the belt of this famous figure. And Mike, I know it's one of your favorites. Why don't you go ahead and tell us the name of this constellation? It, of course, is
Orion the Hunter, Toshi. Thanks.
Orion the Hunter here. So we've got Orion the Hunter, again, famous for his belt stars. He's got his shoulders there and his feet here. In this depiction, he's holding a club and he's got a lion skin shield. And according to the myths and legends, he's fighting Taurus there in the sky as he chases him throughout the sky here. So those are a few constellations that you can be looking for in the evening sky as we get ready to take a look at some other things.
Well, Toshi, I just wanted to let you know, I've got a hedge here in my front yard that is pretty high and it's a little overgrown at this point. Jupiter is getting pretty close to it. It might be a good time for us to look at Jupiter with the telescope.
All right, yeah. So why don't we go ahead and do that? So Mike has already got his telescope focused in on Jupiter here. And again, that was sort of low or getting low over in the western part of the sky here. But let's go ahead and focus in on the view. What is it that we're seeing here, Mike?
Well, Toshi, Jupiter is a bit of a difficult object to image because the planet itself is so very bright compared to the brightness of the little moons, the Galilean moons that you can see. 1, 2, 3. I think there are 4 there, Toshi, but maybe one of them has slipped behind the disk. I can't tell. But
yeah,
anyway,
I think I can just barely make out just to the right of the brightest spot there. With that bright spot is Jupiter. There's a little dot that maybe some folks can see. It is very, very close. It's almost touching the rest of Jupiter there, but that is the moon Io, spelled very easily I-O. And that's the closest moon to the closest of the Galilean moons to Jupiter. But then there's 2 more as you sort of make your way over towards the right. And then there's one moon by itself over on the left side, and that is the moon Ganymede, which is the largest moon in the entire solar system, actually.
right. So then the other 2 on the right side, Toshi, were Europa is the one that's a little closer in. And finally, the last one is Callisto. Callisto turns out to be the one with a radius of its orbit that's as big as those 4 Galilean moons there.
Yeah, and we should know that we call them the Galilean moons because Galilei, was the first to observe them and publish his results. And he observed them in the early 1600s, so over 400 years ago. Galileo was able to see these moons, and at first he thought they were stars, but as he observed them over the course of a month or so, he noticed that they were moving around. And the fact that they were moving is what gave Galileo a clue that they weren't stars, that they were these objects that were orbiting around Jupiter. At the time, people thought everything was, of course, orbiting, going around Earth. But here was a case of something, these moons here, that were not going around Earth. They were quite obviously, through observation here, going around Jupiter. And the periods of these orbits, they vary. The moon that's closest to Jupiter, the one that's almost touching Jupiter in our view right now, it only takes that moon 2 days to go around Jupiter. Callisto, which is the furthest out moon, that bright spot over on the right, the furthest one out on the right, that one takes about 18 days to go all the way around. If I've got my periods correct in my head here. So these moons, they take different amounts of time to go around. But Galileo, because he was a very good observer, he noticed that these moons, sometimes he only saw 3 of them, but a lot of times he saw 4. But he noticed that they were all in a line. And again, in our view here, you can see that they are in a line that goes through Jupiter, those 4 Galilean moons.
All sort of in a plane there, or a disk, sort of, if you could look at it from above.
Yeah, and you don't need a very powerful telescope to see these moons. Keep in mind that Galileo's telescope only magnified, well, his first telescope magnified about 8 times. And the his later telescope only magnified about 20 times. So it's not you don't need a whole lot of magnification to be able to see these moons. And that's because these are four of the largest moons in the solar system, even larger than our own moon.
Suitable for something that has moons that's as big as Jupiter.
Exactly right. And I've lost count now how many moons Jupiter has. Used to be that it had 16. That was a nice number that people could remember, but we started finding more and more and more. And Mike, do you remember how many moons Jupiter has now?
I know it's on the high side of or above 79 or something like that.
Yeah, that jives with my memory as well. I think it's something like 80, maybe a little bit more than 80 now, but it's right around 80. But I know when I was growing up, the number was 16, and it was 16 for a long, long time. But then we started sending space probes. Our telescopes started getting better. We sent space probes like a Galileo, or a space probe called Galileo, over to study Jupiter, and we've been discovering lots and lots of moons ever since here.
Well, Toshi, I'm looking up at the sky there, and it looks to me like the little bit of haze that I saw, the layer of haze, looks like it may have subsided just a little bit. That first quarter moon, or a day after first quarter moon, is looking really enticing there. Shall I move the telescope?
Yeah, why don't you go ahead and do that? And as you're doing that, let's switch back over to Stellarium for the moment here, and we'll give the viewers here a little preview of what we can expect to see in your telescope here. So I'm panning around to find the moon. Again, first quarter moon. We're just a day past first quarter moon, which means that at sunset, even though it's been a couple hours since sunset now, but that means first quarter moon would be right around the southern part of the sky. So now a couple hours later, the moon has moved over a bit. But if I go ahead and center in on the moon and I zoom in with Stellarium, you can see that again, about half of the moon is lit up, a little bit more than half, sort of the right half there lit up. And we've got those darker areas on the moon, those lighter areas on the moon. And there's several different features that we can see and that we expect to see through the telescope with your telescope, various features of the moon here. And we can give just a little rundown of the names of some of those features here. So we've got things like craters and rays and mare. Montes is Latin for mountain range. So these are all things that we can see, that we'll be able to see in the telescope easily. And then we have Palus, which are marshes. These are very small plains, as well as sinus, and then some other features that sometimes get named. You can see them here on the slide here, but they're all different names for different features that we can see on the moon here. And this image that we're seeing here, this was taken from the NASA's Scientific Visualization Studio, which is run out of Goddard Space Flight Center over in Maryland here. But Mike, how's the view of the moon looking for you?
Looking pretty good here, Toshi. I'm going to try and get the whole thing in it here.
All right. So as you're adjusting your focus here, there is a question that's come in through the chat, as well as some more locations from around the country joining us. Again, thank you for everybody joining us here tonight. But the question in the chat that I see is from Haley about, if there are so many moons, what size is considered a moon going around Jupiter? And I don't know off the top of my head the size of the smallest moon that's orbiting Jupiter, but basically anything that's going or orbiting around Jupiter is considered a moon. And the four largest moons is Galilean moons. Those were the biggest ones. Again, they're even larger than our own moon. So they're pretty easy to spot even through Galileo's very early telescope 400 years ago. But as our telescopes got more sophisticated and we're able to see smaller and smaller detail, we're starting to see these smaller moons and discovering them. So again, I don't know off the top of my head the size of the smallest moon, but they don't have to be very big to still be orbiting around. The nice thing is that Jupiter's, again, the biggest planet in our whole solar system. So it's able to gravitationally attract a lot of things of various sizes, from things the size of our moon or larger, like the Galilean moons, to things that are sort of maybe only a few 100 miles across, maybe even less than that, maybe on the order of 100 miles across or so. So they don't have to be very big at all to go around the moon. Just like the asteroids in the asteroid belt, they come in all different sizes. Some are as big as a boulder, and some are sort of almost worlds in their own right there. So I hope that answers your question, Haley. But
So
How's it
Toshi,
looking, Mike?
yeah, it's looking pretty good. We've got pretty much the whole lit part of the moon there. You can see the terminator that's on one side there, where the light part meets the dark part. And there's several craters. What's really cool to be able to look at, and we've done this before, if for those of you who've been with us in previous shows, when objects are on the terminator and when the terminator is sort of toward Earth, you get some really spectacular contrast. I want to start though by talking about not the terminator part, but the rest of the moon. Over there, you see that there are some dark patches. And Toshi's showing it the way that you would see it if you were looking up there with a pair of binoculars. And you can see those dark areas. You'll be familiar if you've been following along with us before. Those are the mare regions. Those are the areas of what do I want to say, molten rock that bubbled up through the surface and ended up filling up crater basins made by asteroids and meteors hitting many billions of years ago. And those dark areas are some of the largest features on the moon. Craters are typically much smaller. The basins, though, can be very large. And when they get filled in, they look dark like that. So let's see here. Let me zoom in just a little bit, Toshi. I'm going to try and get in and look a little more carefully at the mare regions there. Maybe you can identify. I can see the Sea of Tranquility there, and Serenitatis. Maybe there's a couple of those you could talk about while I zoom in here.
Yeah, so then the Sea of Tranquility, that's the sort of the middle of the three. You're kind of zooming in towards the Sea of Tranquility now, just sort of to the right of center in our view here. And that, of course, is where the Apollo 11 mission, the first mission that landed humans on the surface of the moon, landed in sort of the lower right-hand corner, or sort of lower left-hand corner, I guess, of that Sea of Tranquility there. So this is so we're going to be able to at least pass over some of the locations where some of those Apollo missions landed. It's been a long time ago now. Again, NASA is getting ready to start sending more missions to the moon very, very soon, and that's part of the whole Artemis program that NASA is starting to put together as we speak here.
Well, can you still hear me okay, Toshi? I'm standing up at the telescope. It's a little more convenient for me at the moment. Is that all right?
Yeah, we can hear you fine, Mike.
Okay, good. So those darker areas are called the mare regions. The lighter areas are what astronomers refer to as the lunar highlands. And I'm going to drop down a little bit and see if I can show you some of the highlands. And what I'd like you to notice about the highlands, come on, you can do it. There we go. The lunar highlands are dominated by piles and piles of craters. All of the, a bunch of them on top of each other. And I'd like to talk just a little bit about sort of the difference between these highlands and the Maria areas that are the darker areas that Toshi was just talking about. If you look at the highlands are cratered tremendously. And I have a question for folks who are listening in or watching the show here. Look at how the highlands area, that's the part that's very close to the terminator there, the line between night and day on the moon there. Look at how many craters there are there. And then I'm going to go back to one of the Marias here. And let's look and see if we can tell how many craters, relatively speaking, there are in the Marias. See if I can zoom in just a little bit. There's an example that's there. For me, it's on the right. For you, it may be on the left. Let's see here. Sorry, I'm having a little bit of trouble with my control panel there. There we go. If I can zoom in a little bit more here. There's one of these Maria regions. See if I can, you can see it right there. And look at the relative numbers of craters that are in the Maria region, that dark area right there. You can see a mountain range that's up above it there. That's called Montes Alpes. But down below, if you're seeing what I'd like you to pay attention to, there's almost no craters in that area. So my question is, which do you think is older? Which is older, the part of the moon that has lots and lots and lots and lots of craters, or this one here that has almost none at all? Which one is older? Toshi, did that question make sense?
Yeah, I think so. Talking about if you have your different surfaces, we're looking at an area that doesn't have very many craters. And that's kind of what we're looking at now. And so would you expect that area without very many craters to be older or younger than a different area that has a lot of craters on the surface? So you guess you can go ahead and put your answers in the chat and we'll see if we can highlight some of those. And in the meantime, we do have several questions that have come in, some of which I'm gonna throw them all to you, Mike, because I know you have a better sense of lunar geography than me. But there are a lot of questions about things of sizes on the moon, about is there any mountain bigger or mountain on the moon that's bigger than the moon than Mount Everest? And I don't think that there are any on the moon that are taller than Mount Everest. There's a very famous very famous mountain on Mars that is taller than on Mount Everest, but I don't think that there are any keep saying moons. There aren't any mountains on the moon taller than Mount Everest. Does that sound about right to you, Mike?
That's true, Toshi, but you know, I'd have to look that up to be sure. There's that mountain range that is right in the middle there now is I believe about 17,000 feet from low to high. So in other words, if you could look at it from the side, that's what the difference would be, about 17,000 feet. But as far as what is the one that's the biggest, I don't have that information. I'd have to go and look that up. And that would be something that would be real easy to do with Wikipedia, probably could be used to solve that problem. Let's go ahead, Toshi, and let's finish what we were talking about in terms of the ages there. It turns out that the oldest areas on the moon are the ones with the most craters. And that's because what happened to form the Marias is big crater basins were created with huge material like asteroids and meteors, but very large ones hitting with great impact, making some of the largest holes on the moon. And then they were filled in. When they were filled in, they were smoothed out, filled in by lava that flowed into these crater basins. And so the ones that only have a few craters tend to be the youngest features, and the ones with lots of craters are the older ones. That makes sense to you, Toshi?
Yeah, and some people in the chat look like they also have the same idea that the places with more craters are going to be older. And again, like you sort of alluded to earlier, the Mare are ancient lava flows on the moon. So if anyone's ever been to someplace like Hawaii or someplace with volcanoes, active volcanoes, and the lava flows, when it flows and cools, it becomes a dark colored rock. That's what happened on the moon. You have these vast plains where there was a lot of lava flowing on the surface, and it would have covered up older craters and left sort of like a clean craterless surface. And then impacts that happened after that lava flowed and cooled, those are the craters that we see on the Maria there. As we get ready to move on sort of to the next section, another question about what's the diameter of the largest crater on the moon. And it turns out that that crater is there's sort of a crater basin right at the South Pole. And that's about 2,500 kilometers in diameter. That's about 1,600 miles in diameter. So that's a very large impact that must have happened right at the South Pole. And we kind of expect that in the early history of the solar system, there were a lot of things flying around. I mean, you can see just in this view that Mike's showing us right here with all those craters that you can see that there are all sorts of things flying around in the early solar system, crashing into the surface and leaving all sorts of craters of all different sizes, some big, some small. Sometimes you get craters on top of other craters. So the early solar system was a very violent place there. So again, largest crater on the moon is at the South Pole, the Atkin Basin, about 2,500 kilometers or 1,600 miles in diameter. So quite large. Yeah.
Thanks for that. What I was hoping to do, this is the southern point of the moon. And there's a particular space mission that's going to the southern region of the moon in just a couple of years. It's called Viper, and it's looking for frozen water. Did I got that right, Toshi?
Yeah, so Viper is scheduled to launch, and I do have just a quick quick overview of the Viper mission, just scheduled to launch in a couple of years now, late 2023. I think they were actually shooting for a December 2023, although these launch dates, they tend to change. But that's a plan for the moment, late 2023. It's going to the South Pole of the moon. And the mission's supposed to last for about 100 days, and it's looking for ices. It's part of the Artemis, part of the Artemis program to find a place where there might be water that astronauts could use to form a base and to set up camp, a permanent settlement or semi-permanent settlement on the moon. And to do that, though, we need a source of water. So Viper is one mission that's going to help us characterize the area around the South Pole and see if it might be suitable. So that's something definitely coming up here. But we'll go back to the moon because I didn't say it before, but you're getting some pretty crisp imagery of the moon here. I'm actually quite impressed with the views that we're getting here. So keep it up, Mike.
And you know, actually, Toshi, the conditions are quite good viewing wise. We're not getting a heck of a lot of scintillation, that effect that makes everything look like it's sort of underwater. It's pretty good here tonight. I think it's pretty settled pretty nicely. I see, I'm just looking up at the sky, just sort of checking it out here. It looks like things are still pretty decent. I know we've got that atmospheric river that's aiming toward the west coast here, but it's not here yet. So let me go ahead and continue to sort of just walk up the terminator here so we can sort of see what's going on. I'm going to try and improve the exposure a little bit by moving a little bit toward the west. There we go.
And as you're adjusting that, looks like one of our viewers, thank you, Matthew, looked up that Mons Huygens is the moon's tallest mountain, and its height is 18,000 feet, which is a little bit more than half of Mount Everest. So the tallest mountain on the moon looks like it's about half the height of Mount Everest. Thank you, Matthew, for looking that up for us.
Boy, that's great. Yeah, I appreciate the information. That's good. I wanted to point out to people as they look at these craters that if you were standing in those craters, it would actually, you think about it a little bit, and it'll probably make sense that it's sort of sunrise at the points inside the craters where those shadows are so amazingly long. You can see the walls of the craters are actually casting fairly big shadows. This is a time, first quarter moon is a good time for astronomers to be able to measure the scale and breadth of the moon because those shadows are so accentuated. So let's just keep watching here. I love how these things are just all on top of each other, and there's all kinds of what I want to say, detail that you can see there. Let's see if I can move up a little bit further. We'll take
I'm
another.
noticing, Mike, towards the top of the view here, it's actually a little bit more towards the center now, that there's a crater there that looks like it has a little dot in the middle there. And I know we've talked about that sort of thing before, but maybe, Mike, you can shed a little light on what that dot is in the middle there.
Yeah, I love those. Most of the time, when you see something in the middle of a crater, it's a raised section. It's not a depression. But you can have other craters being made by other flying rocks after the first one. But what Toshi's talking about is what I like to call central peaks. Well, it's not, I like it because that's what astronomers generally call it. Central peak is sort of the, what happens. You may have seen it before in, I know when my students and I are exploring how craters are made, we can sort of make them sometimes. You see little bits of material that sort of splash up in the middle as sort of a rebound. Is that the way you'd sort of characterize it, Toshi, as sort of a rebound of?
Yeah. Yeah, and I like to think of it like if you have like a pond or like a little pool of water and you drop a small pebble into it, and where the pebble drops, sometimes there's like a little bloop of water that pops up after the rock has sunk below the surface of the water, that sort of popping up of some water. Well, imagine instead of water, you had molten rock. And that's what lava is, right? It's molten rock. When you have impacts, they crash into the surface, they melt the surface and liquefy the rock so that it acts like a liquid, just like dropping that pebble. So there's molten rock that bloops up. And when it solidifies into like a tiny little hill, or maybe it's not so tiny, depending on how big that bloop is. But it forms a peak. That's why we call it a central peak. It's material that was liquefied, sort of popped up and solidified into a solid feature there.
And Toshi, I've heard some supposition about crater basins. You can see that one that's right in the middle there that looks completely smooth. I don't see any craters actually in there. It's very possible some of these ones that look very smooth are smooth for the same reason that the mares are smooth, that molten material flowed into it and sort of smoothed out the floor of the crater so that you can't see any central peak anymore.
Yeah, exactly right. And so
All
some
right,
places very smooth, some places lots and lots of craters. But this is something that actually Galileo was very surprised by, looking at through his, again, even through his rudimentary telescope, how complex the surface of the moon was. At the time of Galileo, a lot of people assumed that the moon, because it was something in the heavens, that it must have a perfectly smooth surface. But when he looked through his telescope, he noticed that there were these mountains, and like we're seeing now, that there were craters on the surface, that there were these darker areas, lighter areas, but all sorts of detail. And depending on when you're looking, we're looking at a first quarter phase here, but you look along the terminator and you see those shadows, like the central mountain range that you're showing in your view there. You can see the shadows on the left-hand side there being cast by those mountains onto the surface of the moon here. So the moon is a really dynamic thing. And you're focusing in on some craters there that have some pretty deep shadows that we're looking at right there.
yeah, and so you get a sense of which ones are deep versus which ones are shallow. What we're seeing here with that mountain range, and then as it continues around in sort of a circle, it's a partial circle because of the way that the moon is lit at the moment. That is the largest of the Mare regions. That's called Mare Imbrium. And before somebody beats me to it, there's one that actually is bigger, that's a similar type of a feature. It's called, but it's called an ocean and not a sea. And they did that because it's the largest of the seas, so they gave it a slightly different name. Oceanum Procellarum is sort of the name of it. But this particular one, Mare Imbrium, was a huge impact event. It filled, once the the material hit the surface and carved out a huge basin. Like I said, one of the biggest on anywhere on the moon. It then filled back in, and now you can see that some craters have been left on top of that material as well. So we're looking at billions of years of evolution of this surface. It's really fascinating to me. I love to think try to think about sort of the order in which some of these things astronomers have said happened, because it really is fascinating.
Yeah, and again, there are all sorts of things flying around, and as you're sort of moving the view here, sort of on the far right view, but almost to the center there, you're moving a little bit more towards the center. I see a little crater, and I can see a pretty distinct crater inside of that crater. And think about, what sort of a cosmic bullseye that must have been to have something impact after, or in that larger crater there. So it's sort of if you're like playing darts, that's sort of one for the dart champions to get a crater inside of another crater there.
I believe, Toshi, I'm looking, as I recall from my notes, that's the crater Cassini, named for the astronomer who was the one who's also has his name attached to a gap between two of the two major rings of Saturn. And I can't remember.
He's pretty famous in astronomy circles. He did all sorts of cool things. Great observationalist. Came a little bit after Galileo in history.
And I believe he was actually the one that finally convinced Isaac Newton to publish his theory of gravitation. Can you believe it?
Yeah, Newton was an odd fellow, and there are a lot of things that he didn't publish until someone really pushed him. It's like, hey, you should publish this. Like, yeah, okay, I'll see what I can whip up there. Hey, Mike, before you move out of the view, I did want to point out something that I noticed. So sort of to the left of the image there, in the shadowed region, there's a couple of bright spots. Sort of right now, it's in the kind of the lower left area of the view that we're seeing, but I see a couple of bright spots in the shadow. What are those?
Well, Toshi, my guess is those are peaks that only the very top of the peaks are in sunlight now. So if you're at the top of these peaks and you were looking, you would have seen the sun rising over the lunar horizon. And I'm trying to get a little bit of a better focus and a little bit more resolution here. Let's see if I can do that. Sometimes I just make it worse.
But yeah, as you're adjusting your focus there, it is worth noting that looking along the terminator is usually the most interesting place to be looking on the moon with a telescope, because you get those shadows and you get the interplay between things that are taller and things that are shorter. And so you can have those tall peaks that are still, the rest of it is still in shadow. You see the long shadows being cast by the mountains and the crater walls. Like I can see some really interesting shadows being cast just sort of to the right of those two peaks that I was pointing out there. Some really nice sort of jagged shadow line that kind of gives you a sense of that little sort of that short little mountain range that we're seeing there. So all sorts of really interesting details. And every time you look at the moon, it looks a little bit different because of the shadowing there.
Yeah, this is without a doubt, this is my favorite time to look at the moon, just because the contrast is so striking and very beautiful. I know, it's nice to be able to see it as we're seeing it here, but looking in the telescope, I've had a lot of people evidence a lot of oohs and ahs about how beautiful that the contrast makes the view there. And it's so interesting to be able to figure out what astronomers have learned just from the observation of some of those. Of course, nowadays we have lunar samples that have helped us understand what some of the materials going on within the surface and where some of those came from and what their history is. But just looking, it is just absolutely fascinating to me. There's just so much to see there. I guess, Toshi, we might want to move on a bit here. Do you have any questions that showed up related to what we've just been talking about?
Well, there's one question that I can answer fairly quickly. Someone was asking, what is the tiniest crater interesting that they mentioned tiniest, because there are such thing as micro meteorites, which are tiny, tiny little rocks that impact on the surface. So there are micro craters on the moon that are from just very small bits of rock that have impacted on the surface. So we talked about the largest crater on the moon being 2,500 kilometers across in diameter, but there are things that are tiny, tiny, because there are things striking the moon all the time, which is why, you have Neil Armstrong's famous footprint on the moon, which will last a long, long time, but it won't last forever because you get these tiny micro meteorites that are constantly bombarding the moon. So eventually that will get erased, although it'll take thousands and thousands and thousands of years. But there are little tiny impacts that are happening on the moon all the time.
And we actually see, Toshi, we see craters that have evidence of what you would call weathering. It's not atmospheric weathering because, of course, the moon has no atmosphere to speak of, but it's that material that's continuing to come in from space at a very slow rate, of course, but with lots of time, over lots of period of time, you get significant effect.
Yeah, and one more question that maybe this is definitely a question for you, but again, Haley was asking a lot of questions, so thank you for your participation. But Haley's wondering, what type of telescope are you using, and can you describe its use? So maybe tell us just a little bit about your scope.
Yeah, thanks for that question, Haley. The telescope is made by a company called Meade Instruments. That company is now owned by Orion Telescopes. But Meade made a lot of different, very high quality telescopes. This one's called an ETX, and it's the aperture, the part that gathers the light with this telescope is about 4 inches in diameter, very close to 4 inches in diameter. So it's not a very large telescope. I like it because it's easy for me to move around. I don't have to do a lot of lugging of heavy equipment. It fits in sort of three bags, the tripod that I set it up on, and I don't have a separate camera here, so it's hard for me to show it, and it's not actually lit so that you'd be able to see it. But that's what it's called, an ETX. It's also referred to as a Schmidt, it's not a Schmidt Cassegrain, it's Matsutikov. I can't remember the actual basically what it is. It's a folded design that allows you in a very small compact system to get a really good view of whatever it is you're looking at. So you saw what we got to see with Jupiter and with the moon as well. We're going to try looking at something else, a double star system in just a minute. Toshi, what did I forget to say about my telescope?
No, I think you hit the main points there. So if you want to go ahead and switch over to the double star that we had planned, you can go ahead and do that. While you're doing that, there is one more question that I saw that came in the chat. Actually, a couple more. One was about Comet Leonard, and hold on to that thought. We'll talk about Comet Leonard in just a moment here. But there was another question about naming the craters on the moon. Is there sort of some rhyme or reason to that? And it's a good opportunity to talk about if you don't have access to a telescope like the one that Mike has, there is a tool that you can use, or sort of a graphic that you can download from the Goddard Space or the Goddard Scientific Visualization Studio, the SVS. And that is a map like the one that I'm showing here. This has been downloaded from the SVS site, and we will put a link into the chat in just a little bit, and we'll probably put one in the description so you can find it easily if you're watching the video afterwards, or you tell your friends about this video afterwards here. But this is a map that we've shown before in previous ones, programs. But this is a map that you can download here. This one is set specifically to look at the moon this is Universal Time, December 12th, 4 a.m. Universal Time. That translates to 8 p.m. On December 11th. So this is just about 20 minutes ago, current time here. But as you're looking at this map of the moon here, it gives some wonderful names, or names some of these craters, again, looking at the surface of the moon, and you can see some of that detail that Mike was showing us just through our telescope. So you can spend a lot of time exploring the moon. And the nice thing about this website is that you can put in any date throughout the year. They've already come out with the 2022 set of images, but you can put in any date for the entire year and any time, and you can take a look and see exactly what the moon will look like, how these shadows will appear on the surface of the moon. But a lot of these names that you're seeing here of the craters, those are named after various scientists throughout history. So the naming scheme that gets used for the moon is that craters are generally named after scientists. Some of them may have studied the moon, some of them maybe not so much, but contributed to the moon. But they're all named after various scientists. And then there's some other naming schemes that people have for other features on the moon, like the lakes and the mountains and the mare, things like that. They get sort of a different naming scheme. But there is anything that's named in astronomy, astronomers come up with a naming scheme, a nomenclature for how to name different objects on the surface of these different bodies throughout the solar system. So whether that's, features on the moon, or whether they're the names of the asteroids, or the names of the moons orbiting other planets, astronomers, they generally first they agree upon what sort of names they'll give to each of these different groups, different bodies, depending on where they are.
Well, Toshi, I tried to find the double star system that I wanted to show here, but unfortunately, I'm having a little bit of trouble with the telescope. I'm going to show you a video. The issue is that that double star system is in a different position in the sky, and I had a little bit of rotation of the camera, so it's making it difficult for me to actually find the object in there. But given the time frame that we've got here, let me just go ahead and show the video that I took on Tuesday of this week, when we were thinking that maybe we wouldn't have good weather. I recorded it so I can show you. And Toshi, maybe I'll just try my share screen here. See if I can show that. Okay, Toshi, did that work out okay? Are people able to see this little dot right here?
Yeah, I think we can see that there. It's a small dot, but yes, we can see it.
It's a very small dot. I'm going to go ahead and turn on the video so you can watch it. If you look very carefully, this star, it looks like a star to the naked eye, but it actually is two stars, one that's bright and one that's less bright. Okay, so let me start this from scratch here. I think what happened was it started already when there we go. There you can sort of see it. Double stars are all over the sky. And people, if you look with even small telescopes, you'll see that many of these stars that look like a single star are actually more than one. This particular one is definitely one of the more interesting ones. It's a quadruple star system. And with telescope, if you were to look at this with a telescope with a little more magnification, you'd be able to see the difference between the two stars a little more clearly. But this is sort of what it looked like on Tuesday. And Toshi, maybe we can show the slide that has some information about this system. We have a bright star and a smaller star that's right next to it. They're gravitationally connected so that they're orbiting around each other. Let me go ahead and unshare my screen now. And Toshi, maybe then you can show the slide. Stop share. There we go.
All right, so yeah, so we can take a look at a copy of the system here. This is sort of a blown up view here, and there's sort of the A star, which is the brighter one, and it's being orbited by sort of a triple star system. So you've got A and B, they're sort of orbiting around this common point, which is opposite of this other star, C. Together, these three stars, they kind of orbit around like this, and they all kind of orbit around. So it's a very complex system of, again, four stars that are all dancing around. in various ways here. And again, as Mike said, to the eye, it looks like a single star. It's about 260 light years away, but they're all orbiting each other with different periods. So the whole thing orbiting around in a period of something like almost 5,000 years to go all the way around there.
Well, Toshi, I did a little bit of a back of the envelope calculation, knowing that it was 260 light years away. It turns out that that system, those two star systems as they orbit each other, are as far apart as 2 radii of Pluto's orbit. So it's much bigger. It's much bigger than our solar system. We of course don't know about the planets that are there because we can't see. We don't have telescopes that are powerful enough to be able to show that much detail yet. I say yet because eventually, possibly, we'll be able to see that. But I thought it was interesting to show the some of the details of that system because it's so different and from the very simple case that we have here in our solar system. We have one star. We've got another object, Jupiter, which almost became a star, which if it had a little bit more mass, some amount more mass, it would have actually formed into a star, and we'd have a double binary system, as it's referred to. But it fascinates me, Toshi, and the reason I just wanted to show it, beyond it's something that you can, there are a lot of these systems out there in space, and it's fun to find out how different they are from the case of our solar system.
Yeah, and for sure, there are all sorts of wonders in the universe. And in our remaining couple of minutes here, one more wonder to let people know about. You may have been hearing about it in the news that there is a comet that is brightening in display here. And I've put together a little map that shows where you can find this comet in the coming days. Hopefully, the weather cooperates. The comet right now, it's called Comet Leonard. And right now, it's visible in the morning sky, but it's very rapidly approaching the sun. And in a few days, it'll emerge and show up as an evening object. And so this is the path that it's taking in the sky over the course of December 15th through the end of the month. You'll have to be looking fairly low in the southwestern part of the sky. This is looking at 6 p.m. And if you were to track where the moon is, where the comet is, on each night at 6 p.m., the comet will be quite low here in the southwest. On the 16th, it'll be a little bit higher. If we get clear enough weather, you might take a look. Venus will be very easy to spot in the southwestern part of the sky here. And the comet will be just below Venus there. And it may possibly be bright enough to see with the naked eye if you're looking from a dark sky site. Comets are notoriously fickle, though. The expectation is that it will brighten. It may or may not actually brighten, but the 17th might be a good chance to spot it. It'll be right below Venus, again, looking at 6 p.m. As we go towards the end of the month, the comet will get higher, but it will also be getting fainter in the sky as well. So it'll be a little bit trickier to find it as it goes on in time. So over the next few nights, that'll be sort of early morning for the next couple of nights. And then for a little bit after that, starting the 15th, you can see it in the evening sky there.
And Toshi, I believe that people are seeing it from very good dark skies, they're able to see it with binoculars. Isn't that correct?
Yeah, people have been checking it out for a while now. Last week or a couple of weeks ago, the comet made a very close pass next to what's something called a globular cluster. So there were a lot of very pretty pictures that I saw on the internet of people who took pictures of the comet right next to the cluster, and it was just a beautiful image. So the universe is always out there to surprise us with all sorts of beautiful things. But with that, I think we're just about out of time here. So we'd like to thank everybody for joining us this evening here. Mike, why don't you go ahead and say goodbye one last time for everybody?
Well, thanks everybody for watching with us tonight. I hope you enjoyed looking at the moon. I certainly enjoy looking at, especially at first quarter moon every month. I look forward to be able to use my telescope to see some more interesting things there. But thanks again. We look forward to seeing you again. And thanks for those of you who have come to several of the programs. And That's it. Thanks very much for watching.
And we'll go ahead and again wrap things up again on behalf of the entire planetarium staff here at De Anza College Planetarium. We'd like to thank everybody again for watching. We'd like to wish everybody happy holidays. It is the holiday season. Stay warm, stay healthy. And if you enjoy what we're doing here, we expect to do some more of these into the new year. So look for on our social media and our website to find out when we're doing our next program here, whether it's virtually or we're hoping sooner rather than later to be in person again. So for now, thank you everybody for joining us this evening, and we hope to see you again next time. So thanks very much and have a good night.